I'm going to be looking at this step question. Now this is from step 2, 2017. Okay. The vertices of a non-right-angled triangle have position vectors a, b, and c. The non-zero vectors u and v are perpendicular to bc and ca. Write down the vector equation of the line through A perpendicular to BC. Right, so the first thing that you'd want to do with any question that's a vector question is draw it out. So what we've got from an origin is we've got a vector A, B, and let's put this one over here, C. Okay, so let's just label those. Let's call this one A, B, and C. Now, what would also be quite a good idea would be to join those points up, okay, because it forms a triangle. So if I just join them up, I'll get something like this. Right, what else do we have? Well, we've got vectors which are perpendicular to BC and to CA. So let's put those ones in. So perpendicular to CA, so a vector that looks a little bit like that, and a vector which is perpendicular to BC, so it will look like that. And these vectors have got some names. The one that's perpendicular to BC is U, and the one that's perpendicular to, I'll just put that up there, and the one that's perpendicular to CA is V. Okay, so there we go. Write down the vector equation of the line through A, so the one that passes through this point, which is perpendicular to BC in terms of UA and a parameter. So you can actually jump straight in with this one. So the vector equation of the line is going to be any point on that line, well, quite obviously that's going to be A, plus some scalar quantity of its direction. Well, if it's perpendicular to CB, it's going to be this vector U. There we are. So that's the first part done. I can't imagine that would be worth many marks though. The line through A, perpendicular to BC, intersects the line through B, perpendicular to CA. Find the position vector of this intersection point. Okay, so let's just put these points in. So we've got a line which is perpendicular, that passes through A, and another line which passes through B and is perpendicular to CA. Okay, and this point, this intersection point, is called P. Okay, so, well, if we want to find the intersection, we want to find sort of when the equations of these two lines equal each other. So the equation of the line which passes through B and would be perpendicular to CA would be quite similar. It would be R equals B plus some scalar quantity of its direction, V. Okay, so let's set those equal to each other. So A plus lambda U equals B plus mu V. Right, so if we look at the question though, it wants us to give our answer in terms of A, B, C and U. So there's no V there at all. So what could be a good idea is to get this in terms of V and then just see where we can go from there. So if we get this in terms of V, we'll have, well, A plus lambda U minus this B equals mu V, but we can divide by mu, so we have 1 over mu, well, this equals V. Okay, now with quite a lot of vector questions, especially vector geometry questions, what quite a lot of them just end up being is a case of dotting a lot of vectors together, because what we should know is that if we dot two vectors together that are perpendicular, we get 0. Okay, now this vector V, if we want V to disappear, well, we can dot v with something that's perpendicular, it's perpendicular to, which is this vector here, which can be a minus c. So what we can do is we can actually dot both sides of this by a minus c. Okay, we do the dot product of that. So the left hand side will be 1 over mu a plus lambda u minus b dot of a minus c, and that will equal, well, v dot a minus c, which is just 0. Okay, now as it equals 0 and this is just 1 over a number, we can actually just get rid of that by multiplying both sides by mu, so that can just disappear. Now what I want to do here is I want to expand this out because I want to find out what this value of lambda is, okay, or get an expression really for that lambda. So I've got a minus b dotted with ac, so this is going to be a minus b dot with a minus c, and I've got plus lambda u, which is dotted with also this a minus c. So if I rearrange this, okay, well, I'm going to have this on the left hand side, and I'm going to bring this over onto the right hand side. Now, instead of writing minus, I mean, there's no wrong issue if I were to put this as minus lambda u a minus c, but rather I can sort of factor in that minus into here and change it to a c minus a. Okay, and that equals this here. And so, well, lambda is going to equal, well, this, so a minus b dot a minus c, all divided by u dot c minus a. Now, it doesn't look the nicest thing in the world, but that's our answer. Okay? Next, so let's give this a tick. Hence, show that the line CP is perpendicular to line AB. Okay, so CP is this line connecting like so. Okay, so I may just put that in as well. Okay, so CP. As you can see, it does actually look like it would be perpendicular, but we've got to be a bit more rigorous than that. Okay, so what we'd want to do is, well, we'd want to find out what CP, if we want to show that something's perpendicular, well, like sort of what we've been doing since the very start, we'd want to know, or test out CP dotted with AB, and we'd want our answer to equal 0. Okay, we can't say it equals 0, we want to show that. So, what's the vector C to P? Well, we know what the vector O to P is. Okay, O to P is A plus lambda U, where lambda is this. So let's just write that, A plus lambda U. Okay, I'm not going to write this every time. It's much easier to just write lambda, and this is what we define lambda as. Okay, so that means that C to P, well, that's going to be minus C plus A plus lambda U. Okay, now vector AB doesn't really matter how we define this one, as minus B plus A or minus A plus B, doesn't really matter, but I'll just keep it alphabetical and call it A minus B. Okay, so let's dot these two together then. So if we dot them together, we have minus C plus A plus lambda U dotted, oops, put that in the wrong place. Oh, just get rid of that quickly. Dotted with a minus b. Okay, and we want to see what that gets. Okay. So in any case like this, I'd always sort of I'd like to get this vector u on its own, because that's I feel like that's going to be quite important. Okay, so we can write this as minus c plus a dotted with a minus b. Okay. Plus lambda u dotted with a minus b. Okay, now none of this is immediately screaming out to me as equaling 0. I'm just going to write this minus c plus a as a minus c. Okay. So a minus c is this vector, a minus b is this vector, so there's no immediate answer there. U dotted with a minus b, which is this vector, and once again, there's nothing there. So what you want to do in a situation like this, because we should be trying to get an answer of 0, is we may need to do a little bit of jigging things around. Okay, and one thing that we can sort of look at is that, well, this vector u, when dotted with this vector b minus c, we get 0 because b minus c is perpendicular to u, and from that we get an identity that u dot b would equal u dot c. Okay, just by expanding it out, you know, u dot b minus u dot c equals 0, so u dot b equals u dot c. So this here then, as u dot b equals u dot c, we can actually rewrite this b as a c, and then we end up with an a minus c bracket here, which we might actually be able to factorize. So let's give that a go. Right, so a minus c dot a minus b plus lambda u dot a minus c. Well, we can factor out that a minus c. Now this may actually, speaking to the A-level students here, you don't really get much practice in the A-level of dealing with algebra, with these vectors and you know, dot products, etc. So the vector questions, I think that's why quite a lot of people don't actually answer them, is that they can be quite put off, because you don't really encounter all of this stuff. It is on the syllabus, but yeah, it's not rigorously tested, is it? So a minus b plus lambda u. Okay. Right, so it looks like we're going to be cooking on gas here, because a minus c is this vector here, and a minus b plus lambda u, well, a plus lambda u is the vector o to p, right, from here. So minus b plus this vector op is this vector here, which goes from b to p. And well, so this is parallel to vector b to p. Okay, which is at a right angle, well, it's parallel, sorry, to this vector v, right? And we're told at the start of the question that vector v is perpendicular to this side, which is a minus c. So this vector here, if you think about it, it's b to o, which is minus b, plus a plus lambda u, which is o to p. So it's this vector here is what we've got. So the dot product of those is going to equal 0. And therefore, we can say, I might need to make this a little bit bigger, therefore we can say that these are perpendicular. It's quite difficult to write on here, but there we go. Okay, so as I say, with quite a lot of step questions, especially ones like this, they sort of just want you to dot a few things together, mainly, well, things that are perpendicular, okay, because then you get things that equal 0, you get things that end up cancelling out, like over here. So yeah, the more you see, the better equipped you'll feel to attempt these questions on your own.